So we're going to learn a special form of factoring today. This is called differences of squares. I want you to look at these four sets of binomials. Notice that they each have the same first and last term, x2, x and 2, a squared and 3b, xy and z, 2n and 3. The only difference is the sign. One of them's plus, one of them's minus, and it's true all the way through. What I want you to do first, I want you to pause the video and I want you to multiply these binomials. I want you to see what happens every time. There is a pattern. I want you to see if you notice it. When you notice it, you can use that to skip some steps, but then turn the video back on and check your multiplication. All right, how'd you do? Did you get that each time the two middle terms had opposite signs and they canceled? Minus 2x plus 2x went away. Minus 6n plus 6n became 0, canceled. 3a squared b minus 3a squared a squared b, gone. Minus xyz plus xyz, gone. And each time you were left with a difference. You were left with subtraction. So this is a difference because it's subtraction. And the other thing about this is the first and last term are perfect squares. X squared is a perfect square. 4 is a perfect square. 4n squared is 2n times itself, right? So it's a perfect square. 9, of course, is a perfect square. A to the fourth is a squared times itself. So it's a perfect square. X squared y squared is xy times itself. So it's a perfect square. So these are called differences of squares because it's subtraction and because each of the terms is a perfect square. And we're going to use this to help us factor a difference of squares. Okay, so here's what you do. First of all, you notice that it's two terms. It's a binomial and it's subtraction. That's a difference. Then you look on the end and you ask, are these perfect squares? Is a squared a perfect square? Of course it is. Is 16 a perfect square? It is. Its square root is 4. So that's the next step, is to find your two roots. Your two roots here are a and 4. Okay? And then whatever those roots are, you're going to set up your two sets of parentheses and you're going to do the sum and the difference. So a squared minus 16 factors into a plus 4 times a minus 4. You could check this. A times a is a squared. Minus 4a plus 4a would go away, and 4 times negative 4 is negative 16. Let's look at the next one. Is 9 a perfect square? It is. What's its root? 3. This is a difference. This is a binomial. What times itself equals 4b squared? 2b, right? So you take those two roots, you say 3 plus 2b and 3 minus 2b. If you reverse the plus and minus, if you put these in the other parentheses, that would be okay. Not a big deal. All right? Now let's look at the next one. 25a squared minus 36 x to the 6. Are these perfect squares? Well, this one we can handle pretty much without any trouble, right? 5a times 5a is 25a squared. So the root of 25a squared is 5a. Now, what about the next one? We know that the square root of 36 is 6. What about x to the 6th? What times itself equals x to the 6th? Well, here's what you need to know. If you have an even exponent, every even exponent is a perfect square. And the root is half of the exponent. So the square root of x to the 6th is x to the 3rd. Because, remember, when you multiply with the same base, you add the exponents, right? So 3 plus 3 is 6. That's why you take half. So there are our two roots. So we would say 5a plus 6x cubed and 5a minus 6x cubed. Remember, it doesn't matter where the plus and minus are, just the roots. Okay, so here are 4 for you to try. I want you to pause the video. I want you to copy and try these 4 problems, then check your work. Alright, see how you did. Now, you do not have to show where you find the roots. That's just for your help. You may want to do that until you get used to this, but you will typically not show this right here. You will go straight from the problem to the answer. Now, I want to show you something they do, especially on math team tests or ciphering, that they love to do to make sure you're paying attention. They love to use powers of 2, like 4 and 8 and 16, because there can be something that happens here that if you're not paying attention, you'll miss. So let's say we're going along here, we say, okay, this is a difference. Yes, these are squares, so what? This is a squared, this is 9, so my difference of squares factors into a squared plus 9 and a squared minus 9. And we think we're done, but we're not. Look at this binomial right here. It's a difference, and this is a perfect square, and this is a perfect square. This one factors again. This has a is a root, and 3 is a root, and this factors into a plus 3 times a minus 3. Now over here, these are perfect squares, but that's a sum, okay? Very, very, very important. A sum of squares does not factor. It can be perfect squares, but if they're added, it doesn't work. So all you can do with that is copy it down. So a to the 4th minus 81 factors into this. It actually has 3 factors, a squared plus 9 times a plus 3 times a minus 3. They love to do this with ones. If I have, let me go to a new page just to show you, but copy this next one too. Alright, a to the 8th minus 1. A to the 8th is a perfect square. Its root is a to the 4th. The square root of 1 is 1. So I know that this factors into a to the 4th plus 1 and a to the 4th minus 1. Okay? Now the sum of squares does not factor, but this is another difference of squares. The square root of a to the 4th is a squared. The square root of 1 is 1. Now this is also 2 perfect squares, but it's a sum. So all we can do is copy it, a to the 4th plus 1, and this next one we have to factor into a squared plus 1 and a squared minus 1. And we go, whew, I did it twice. But then we have to look again. Here's a difference of perfect squares. Now these are sums of squares, so they're done, but this one will factor again. The square root of a squared is a, the square root of 1 is 1. So I copy this first one, it's a sum of squares, it does not factor. I copy the second one, it's a sum of squares, it does not factor. But this one factors into a plus 1 times a minus 1. So if they use a power of 2, 4, 8, 16, 32, and they use 1 as the other part of the binomial, you could be factoring a while. So make sure you pay attention. If you were to re-multiply all of this, and I would start down here and then multiply by that and then multiply by that, you will end up with a to the 8th minus 1.